You are listening to Deep Neural Notebooks, a podcast where I like to discuss a multitude of topics ranging from deep learning and computer vision to neuroscience and open source software through conversations with experts about their thoughts on the state of their specializations, how things fit into the bigger picture, their journey so far, and the road ahead. I believe that it is through conversations like these that we can boil down the essence of vast resources of knowledge and expertise into more consumable bits that can enrich our understanding of concepts and technologies that are shaping our world. For the second episode of Deep Neural Notebooks, I talk with Thomas Wolf. Thomas is the Chief Science Officer at HuggingFace, a Brooklyn-based startup that aims at building the first truly social AI. Thomas has had an interesting educational background, which includes a PhD in quantum physics and a degree in law, followed by a 5-year-long career as a patent attorney before his passion for science brought him to Hugging Face. Thomas and his team at Hugging Face believe in the power of open source and have been active contributors on Github, sharing their research and progress, allowing the development of technology for the better. In this episode, we talk about his diverse career background, his journey from physics to law to deep learning and conversational agents. We also talk about the vision at Hugging Face, the challenges in building a long-term companion-like conversational agent, the state of natural language processing, and how we can do better. This podcast is also available on Apple Podcasts, Spotify, and Google Podcasts. So if you like the content, please subscribe to the channel and leave a thumbs up or a 5-star rating depending on the streaming platform. Thank you. Right. So hi Thomas. Thank you for coming to the show. So how are you doing? How's your day?
I'm good. Yeah, a lot of things going on, but I'm happy about that.
Right. So you're in Netherlands now?
Yeah, I'm close to Amsterdam, living there with my family.
Right.
As you can,
Oh.
as you can see on my not very serious background.
I can see those
Yeah.
cute drawings there.
Yeah. So yeah,
Right.
we have actually all the rest of the team is in New York and Paris. But I'm in the Netherlands, and we may have a little team in the Netherlands too soon. Let's see. I would like
Cool.
to have more people here. Yeah.
Right. So let's talk about your journey. So I read somewhere that you started with programming when you were 10 or 12 years old. So is that true?
Yeah. So
Right. So what were you
started
working
very
on
early.
those days? Like,
So it was very old computers, right?
right.
It was in the 90s, so there were no internet.
Right.
So my father has this old computer, which was this more like a calculator, and you could program in BASIC on this.
Okay.
So I was programming on that, and then at school we had Texas Instruments, the calculator. So I had a TI 89, I think, yeah, and I was programming on the assembly on this. So that was my first thing, and then on the computer. And C++.
Right. So I read somewhere that you were making some video games or something.
At that time, like a lot of visual graphic stuff, but nothing that really was complete enough to put it on the internet.
Right. So do you remember your first project as such? Like something
My
you
first
made?
project?
Yeah.
Oh yeah, so I think my first project is the first one that was on the internet was in 2003. And that was one of these computer game on a calculator. I think it's still out there, actually. It's still.
I'd like to see that.
Yeah, you can check it. So there is this game called Worms, Armageddon. Do you know this game? That's kind of old now.
I know Snake.
So
I don't know Worms.
Worms. There was you had little teams of worms that were fighting, and you were like using rockets and grenades and a bomb to crush the other worms. So I made an implementation of this one on a calculator, like on a small in assembly. I can send it to you, the link to you. Well, that was me at a very young age, though.
Right. But programming wasn't something sort of that you pursued for your undergrad, right? So you did your undergrad in Ecole Polytechnic, I think. I mean,
Uh,
how you sort of didn't go for sort of with programming for your undergrad, and then what was the thought process like sort of back then?
oh yeah, so it's kind of cultural. So in France, we have a very strong hierarchy. That like math are really the top thing you can study, and then theoretical physics is maybe the second top thing you can study, and then physics and computer is used to be quite far down, which is stupid, but we are like this is how the like the history was made, right? We have
Right.
Descartes and all this. And so yeah, I was not really considering this very seriously actually. So I was more focusing on math and physics, and so that's why I did my engineering school, like focusing on physics, and then doing even a PhD in the field, which is I think physics is still like super interesting. I was working on condensed matter, which is on superconducting material, which is like a mix of quantum physics and also statistical physics with phase transition and everything. That was really cool. The main problem with physics, in my opinion, is that the time scale of experiments is very long. When you do like experimental physics, like you need 3 to 4 years to get one experiment, you know, while we do
Completely
that
sort
in
of
like 3 months.
contradictory to sort of computer programs wherein you could just write
Exactly.
something in
Yeah.
a week or so and then have sort of good results.
Yeah, exactly. So the math are actually very close to machine learning math. I didn't know that at that time because I was not just didn't really met machine learning machine learning before, and so I didn't know that. But the math are really close. Phase transition and neural network, variational inference, they're all really the same thing. Well, they actually come from physics. When you look deep in the equation, like variational inference is just all about physics, and there is a lot of things that goes in common to when you compare phase transition and also a neural network and all this information theory. They're really related to kind of physics concepts like entropy. It's really the same, really. And but using this math, if you do physics, you need like a long time to get an experiment going. While if you do some computer science, you can test something super interesting like 2 weeks, and then have like a revolution in a few months. So it's really it fits better the way I like to work. So, but my journey to this was very long because I just didn't know about that. So I was doing this physics thing. I was like, this is too slow. I need something different. So I switched completely. For a long time, I was actually a lawyer. I had a friend who was a patent attorney, and he told me, yeah, that's kind of cool. So I looked into it, and I was like, okay, I like writing. Law is interesting. I've never studied law, so I studied law. That was actually super interesting. Also, it's very logical. I thought it was like all a big mess, but when you dive in law, you're like, oh, that's just actually a very beautiful construction that we human have made. Yeah, I spent 6 years doing that, and then at the end, I had actually a lot of. I was doing intellectual property for a lot of startups. I had a big portfolio of startups, and a lot of them were starting to do deep learning. That was the beginning of the big comeback. It was in 2014. They were doing like computer vision, and then I was writing their patent. So I was like, hey, actually, I know this math. They look like something I know.
Right.
And the more I was diving to it, the more I was like, oh, this is super cool, actually. That's like the mix of the two things I like, which is computer science, but I don't do really this, like programming, but I don't do it anymore. And also the physics equation that I liked. So, yeah,
Right.
that's how I kind of came discover the field,
Right. So
basically.
were you like writing patents for the network implementations of startups back then, or like, so can companies sort of file patents for the networks that they're using for their applications?
That was very difficult because there's a big debate in patent law, which is should we patent software or not, software and AI. I think a lot of this is very hard to patent, and I think it's a good thing. So like it was very difficult to find something that was novel and like that would fit the requirements of intellectual property law. But I think it's a good thing. Basically, I think patent law really works very well for hardware, like mechanical. I also had a lot of startups working in mechanical engineering, inventing new mechanical device, and I think really patent law is really well made for that. And for software, it's I think most of the time we should not have patent basically, but there are some interaction between software and hardware where you're like, okay, that could make sense. One example of startup I had was one who was doing in the fields, when you want to clean the bad crops, the weeds. When you're doing this, you can also have a computer vision that detects the bad plants that you don't want, and so you only spray on this one. So it's like a lot better actually for everything. You use a lot of you use less. What's the English word actually? Yeah, the product that kill the bad weeds, and also it's cleaner and it's just
Pesticides.
nice user. Yeah.
Yeah.
Yeah, exactly. Yeah.
Yeah.
So
Right.
this was this kind of thing, like integrating a deep learning model in like a real life, a real world engine that would go in the fields and like have to clean this.
Right. So before we sort of go into your deep learning career, your machine learning career, so I wanted to know that I read that you got accepted for a PhD at MIT. So what were you going to pursue there, and why did you sort of switch
Oh
to
yeah,
quantum physics?
that felt like a long time ago, but yeah, that was like 10 years ago, not 12 years ago. So at that time I was working on laser plasma interaction. There's this like super cool stuff where you can have super short electron and heavy particle generator using the interaction of a intense laser on a plasma. So I was doing that in Berkeley, in California. I was working in one of the national laboratories. There's a national laboratory on the hills behind the Berkeley campus. And so I was there, and I was like, okay, the US is great, so I should maybe do my PhD there. So I applied to the MIT, and then I was accepted in this general. You're just accepted there, and then you need to find some advisor who you want to work with.
Hmm.
And I would have worked probably on two topics. One was theoretical, more like trying to deduce from very first principle, trying to model how atoms interact. It's like some people are trying to make very basic, not very basic, but very fundamental simulation of quantum thing, like basically build a quantum simulator of what's happening to the particles. It's very complex to do. It's very tough to do, but it's super interesting. And another field was more in like battery, like trying to get better, more efficient batteries. Well, that was also before Tesla, but now it's even more interesting, I think. But yeah, and then I also applied in France, and then I had a hard time deciding where I should go. And then it's, well, I mean, life goes on. It's hard to decide. The main difference for me was the length. I was like a PhD at MIT is 5 years. If you start a PhD in France was 3 years, and at that time 5 years looked very long to me.
Even
I
closer
don't
to
know where
home,
you
France
are.
would have been closer to home, so that's obviously a preference.
Also,
Right?
yeah, you want to stay 5 years away from family. It's always hard to. I don't know. You're doing master degree, or are
No,
you
I
further
just
in your?
completed undergrad in May. So I'm
Okay.
planning to do a master's in some time. So even I have an option of doing it in the US, or probably
Mm-hmm.
staying in India here with my family, and then sort of. So that's a dilemma I have to sort of figure out.
Yeah, it's very hard to choose, right? And
Right.
if you stay 5 years in one country, then probably you will settle there and build a
Right.
family there.
Right.
And you want to really build a family in another country? It's a very big decision. It's hard
Right.
to choose.
Exactly.
But in the end, also the contact with the advisor is like super important. And I had like a very good relation with my French advisor. He was like super friendly. we were playing music together. We were doing a lot of things that you can't really do. I wouldn't have done with the MIT advisor who had like 20 students already and was really busy. So it's very good to choose the people you work with. I think it's the most important in many cases, just to be sure that you will be happy with your boss. And I don't regret at all. I'm really happy about the choice.
Right. So after your PhD, you switched to law. You studied law for a year or two, I think, and then you sort of pursued law for 5 years, I think.
Yeah, so I studied actually while working. There is well, they are okay to hire people even if they don't have law degree when you're a patent attorney, but then you have to take the night school, like you work at night to study, and then you pass the degree. It's okay because it's really hard for people in like patent attorney. It's really hard to find people who both have law and tech degree. So usually you have one of them and you study while working for the other one. And so I did.
Right. So after law, you then switched to machine learning. I mean, I read this online that your friend sort of was building a startup, and then during that time, sometime before, I mean, you had started learning about these machine learning concepts and everything. So before we talk about Hugging Face and the work you do there, I'd like to know that how you sort of became well versed with machine learning concepts. You self-educated yourself. So how was that process? So what did you do? I mean, you went through books, online materials, learning tutorials. So how was that process?
Yeah, so so the way I did it is very I mean, everybody probably has to learn his own way. So my way of learning is usually to find like very exhaustive books, like big books, like real thing that I can read, and just read them, doing the exercise and read them cover to cover and writing notes. And like, so I read like 3 or 4 full books. I think they're all very interesting. I think if I could give one advice, I think sometimes online learning is a bit overrated. I like better offline learning, as I call it, which is reading books, because online learning, a lot of the blog posts you will find, they're written by beginners basically who are also learning. It's a good way to learn to write a blog post, but only reading blog posts from beginners you won't see the full big picture behind it, because when it's somebody who is like senior in the field who writes even in introduction blog post, there is actually a lot of underlying whys. I don't know, like
there's a background that comes from their experience, so they can put that in their words through the blog. But that's not
even
something that you can
simple.
have a beginner sort of blog writer get that into their posts.
Yeah, just because they are still learning, right? So they will tell you basically what they have understood, but maybe there are something like they can't really tell you, oh, this is very important and this is not important, just because they don't know yet. So I think it's good to really carefully select what you read, and the more we go into this increasing exponential production of AI blog posts and AI sharing knowledge, which is great, I think. But the more we go into this, the harder it is actually to tell the good from the bad, I think, and to be sure that you are reading something from somebody who actually is very good also. So I think it's good to be very selective in what you read, and usually the best way for me is just to buy like a good book that people say it's a good book. And the books are also underrated, I think. People think we find everything online, but you won't find everything. Like reading Kevin Murphy, probabilistic approach to machine learning is just something you won't be able to make it by just reading online blog posts, I think. Yeah.
So compared to more formal ways of education, like attending school or college and universities and sort of attending lectures, so compared to that, how was this process of self-educating yourself? I mean, could you draw any comparisons between the two?
Yeah, so I think just making it from book alone is also very difficult. So I think in the end, after you've read a little bit, it's good to see where you feel like you're kind of weak. So for me, on the on the statistical method, there was something I wanted to like dive back into it again. So I took a few classes. I took one classes from EDX. Just basic probabilistic models, and like diving back into this. And also took a few Coursera the Coursera class on the graphical models, because I felt like I was also a bit lagging behind. And this is good because you will be forced to do a lot of exercises and to confront to the things that you may not be sure you really know well. So yeah, you need to do that, I think. But then in the end, I'm really impressed by how you can, if you're motivated enough, how much you can learn from an online experience only. That was my first experience of really learning only on my own. And I think it's really good. The good thing is that you can really focus on the things you want to learn. So you're always like super motivated. So that's really great. While you go to university, there is like half of the class, you're like, I don't really like this. So I'm not interested in.
Right. So you're working for an NLP company now. So what, I mean, about natural language processing. So how did you, I mean, get into natural language processing? Was it before you joined Hugging Face, or was it after?
Yeah, so the way it happened was that one of the founders, Julien, was also a former classmate that was with me at École Polytechnique, and he actually did a few startups while I was doing my PhD and on low career, and he was starting a startup on conversational AI, trying to build an AI friend for like a long term an AI friend. That was quite bullish at the time. And we just ended up talking a little bit about like neural net and how they were doing. And I was looking into maybe following a full NLP classes to also catch up a little bit on linguistics, more like computational linguistics. And so we decided we would follow the class of Richard Socher at Stanford as like independently follow, just build a small group of people who would like meet every week or so and try to watch one class and do the exercise. And so we decided to start that together. That was actually very successful. I think we had to block the little study group. We posted about it. We had like 30 applications. We're like, no, this is too big. We don't want to start a full online classes. So we just took the 10 first or the 12 first people who subscribe, and then we did the full Stanford class. Which was very cool, because also in the end we now have Richard Socher as an advisor in the startup. So there's like one full circle being made. And so at the end of the class I was like, okay, I like that, and I want to do more science and this. I want to come back. And then he was then he and the other co-founder Clement just had raised a little bit of money at that time, and they were like, yeah, why don't you come and you start to do some science in the company and see what we can do. And basically that's how it worked. Right. So the cool stuff, as always, was that I knew I could work well with them. I knew I would be fine with them because I already knew them from before. So there was a lot of it was quite an easy transition, actually.
So how did the name come about, Hugging Face? It's quite an interesting name. Do you know how that came about?
In the beginning, it was very hard to explain to people it was a real company. Now it's kind of well known, but in the beginning they were like, "No, this can't be a name of a company." So the name comes from the emoji. This emoji with hands on both sides, and so our first project was this conversational AI, which was more a bit like a game. So it's kind of like a Tamagotchi game, basically. And the target audience were like teenager, millennials, like very very young audience that would learn, that would like to play with this kind of game. So we wanted something that would be very funny and like just very positive and cheering. And so that's how we ended up. And also the name is a bit strange, so like people remember it also. So that was a cool stuff as well. When you have a complex name, that doesn't mean anything. People have a hard time remembering.
Right.
Now so now
you guys have the emojis everywhere on on the website and everywhere. Yeah. So does that emoji even appear on the sort of the formal documents? Or is it only for
We
the
could, yeah,
website?
no, you're right. It should be. We should put that on all the formal documents.
You'll probably
I'm
be the
writing
first
this down.
company to
Yeah.
have sort of that. Right.
Now
So
we
at
can.
Hugging
With
Face,
it. Mhm.
right, sorry. So you're developing a conversational agent that sort of has open domain conversational abilities,
Mhm.
and that is built for like long-term relationships. Like, so so I read this quote you gave somewhere. So you mentioned that we aren't trying to replicate human-to-human conversation since our AI is not faking a human partner. It's instead designed to be a different kind of intelligence.
Yeah,
So what do you mean
that's
by different
also.
kind of intelligence?
Oh yeah, the I mean the a very deep. I think a very deep opinion or feeling that we have at Hugging Face is that we want to use AI to extend what we can do as human, and like we want to use AI as not something that replace human, which is I think the bad way a lot of people are using or want to use AI. I think so it's not a good take on it. You should take it more like something that lets you do something you could not do before, and so we don't want to fake human. I mean, it's like when you read what the Miss Azabis is saying from DeepMind. Like they want to use AI as a way to like extend research, like to be able to access to develop research or science theory that we cannot do as human. That's also the same idea basically. That we want to use all these capabilities of AI. Like in our case, we are especially interested in all the generative capabilities. The fact that AI can generate unpredictable stuff, or not really unpredictable, but novel stuff that we would not have thought about. Which in NLP is the reason why we started with conversational AI, which is the most like generative, creative way you can use and you can use AI in NLP, something that's super interactive and that generate that generate new text and new image and everything. And so we were very interested about this, this creation that can be possible with AI, creating something that's new, and that's the way we wanted to do it. So the RAI, when we were building this conversational AI, we are still working on it, even though now we have so much in open source that it's not the main focus anymore. We wanted to like play with all these new generative capabilities, like generate new images, generate funny text, generate new interaction with people. And so if you restrict yourself to just copying what humans are doing, you're actually not using AI to the full potential and not the most interesting part. And if you say, okay, I don't need to copy the human, I can just use it for like the craziest stuff I can think about, or like the most exciting thing that I can build with it without just having to copy human, but just being free to do whatever I want, you're actually more free to do a lot of interesting things that you wouldn't have do if you even just wanted to replace a human. So yeah, that's a very deep opinion that we have on how AI can be beneficial for society also.
That's quite a beautiful view that you shared. So, what
Yeah.
are the challenges that you face sort of building these conversational agents that can be sort of more multi-domain and sort of that can be more sort of real-like? So, what are the common challenges or the bottlenecks that you've experienced along the path?
Oh yeah, there are many. I mean, it's a very tough, but that's probably the most difficult, I think, field. I mean, there are some stuff that are easier because we don't want to copy humans, so we can do stuff that are not exactly in the human textbook, and it's still fine if the interaction is funny and if the interaction is interesting. But there are a lot of stuff that are very difficult just because it goes out of the standard supervised learning paradigm when you have to interact with a human. And it's also hard to put that in a reinforcement learning setting because the action space is really big. You can do whatever you can do a lot of things when you interact with a human. You're very free. You just don't move, and you don't just move in 3 dimension or 2 dimension. You can build like an exponentially big tree of possible responses. And so it's really hard to like basically just train models basically. And then we made some progress in that, and a lot of the recent progress we've made were using transfer learning, and which is also why we open source of some of the tools we were using, and they have caught a lot of interest in the community, which is why now we spend actually a lot of our efforts working on these open source transfer learning tools, like our transformer library. So we made some progress on training these models, but it's still like really hard, and really hard to have good long range context, like keeping track of what the user said, keeping track of what the model has said, and then all these problems which we are still working on, which are very interesting, which is combining basically these models with some rules and some better world knowledge, so they don't contradict themselves, they don't say things that are just plain stupid, even though it's okay when it's funny in the chatbot game, but it's not really. I mean, we would like to control this rather than just have it as a feature, which is that it's not always relevant or it's not always logical. So in like mixing logical rules and like more common sense with deep learning models is one of the key challenge, I think, for this.
Right. So you guys got the first position at the Con VI2 competition at NIPS 2018. So in competitions like these, what are the usual metrics to evaluate the performance of a chatbot or a conversationalist agent?
Yeah, it's a very big topic actually, and I think that was one of the main takeaway of this competition, which was that you can be very good on automatic metrics and still not very good on human evaluation. So these are usually the two big category of metrics in NLP, because all automatic metrics are kind of low. They are really hard to get to be really related to human evaluation. Like it's really hard to design good metrics, in particular for generation, just from the fact that generation is a very high entropy task, which means that you have a lot of possible answers, and the gold answer that was written by one human is almost never the only answer that you could do. So it's really hard to say if something has no word in common with the gold answer, is it a bad answer or not? Well, you don't really know. So we are making progress on that. Actually, we've been working also a lot on that, on the scientific and academic side. Like, for instance, this summer we organized a workshop at NACL, which is one of the big NLP conferences, a workshop called Neural Gen, where we were trying to like summarize a bit what's the status on the metrics and how you can evaluate these generative models and how people are trying to improve that. So there are improvements using more, also using novel model like BERT. Like BERT can have a nice semantic space if you train it well, that can put two responses that mean the same thing but are written with totally different ones, that can put these two response clauses in one space, so you can know they are kind of related. So you can use this large scale pre-trained model also for the metrics, but there's still a long way to go to be sure that when we have a good score on one metric, we will also have a good score on human evaluation. And I think one additional problem with chatbot in particular, and like conversational AI, is that there are a lot of dimensions. Like you can have a response that's boring but fluent, boring but grammatically correct, one response that's actually very interesting but has some mistakes, but it's fine. So you have a lot of directions along which humans evaluate the response, and they are kind of orthogonal. So it's hard to know really what's matter for you. Is it more important that the chatbots reply in an interesting way, or that it reply in a grammatically correct way? So it's there's a lot of things that there is progress on this frontier as well, but it's a very tough problem. Very interesting as well,
Right.
I think.
Even I feel, compared to other sort of computer vision problems or problems in other fields, the natural language generation is quite difficult. As I mean, yeah, like you said, so there's a lot of dimensions there. So first you have to be accurate with the response. So you have to uh, the entity extraction has to be good. The intent classification has to be good. What based on what you get from the user, your response has to be. It could either be funny or it could be sort of more serious depending on what you got from the user. So since you're tackling something that is sort of more social, a more social kind of an approach or a social domain, so how do you think you could make, so you could add that apart from the general intelligence of a chatbot, how could you add that emotional intelligence to a chatbot? So I mean, those specific things that could make a human feel better while conversing with a chatbot. I
Mm.
mean, how could that process be more sort of intimate and
Yeah,
beneficial for the user?
yeah. I think so. So there are usually two. If you don't go end to end, but if you look at the pipeline, there are usually two things. The first one is really understand what's the emotion that the user is conveying. So for that, actually, that's one of the first thing we've tackled. Um, so it was we used one model called DeepMoji, which is trained on Twitter. That was actually, I think, one of the first success story of transfer learning in NLP. That was a model by Bjerkfelbo, where they trained an LSTM at that time to predict the emoji that people would add to their tweets. You just mask the emoji. You take they took, I think, like 4 billion tweets or things like that. So really a huge data set, and you train the models to predict from the text the emoji. And what you discover is that when you use this model, you can transfer it to many sentiment detection tasks, and it has very good performances. So a bit like now the NLP kind of thing, but that was before the BERT and before everything like this. So we also have an open source model that's called Torchmoji, which is DeepMoji for PyTorch. That was also the beginning of PyTorch. We were really excited about that. And this model is kind of good to classify, or like to try to get the general feeling of the user. And then the other thing is how you reply to this user with the good feeling. And here, I think a bit like everybody, we had to be very careful, because we want to have our long-term companion, like the conversational AI. We want it to be a very positive presence in your life, like something that's really positive and cheering you up. And the main conclusion that we had at that time was that basically you need to control the generation a lot to be sure that it's really very positive and that it's very good quality. And so we made a very complex mix of templates and some part which are fully generated at some point where we're okay and we know we can trust the models. And then for the other, you select one general kind of template and then you fill it with more specific things. So you have to be very careful about the generation. And yeah, I think this is evolving, but yeah, this is some place where we definitely cannot really cannot trust the neural network models yet.
Right. So you guys have open sourced most of this, I believe. So what is the company's sort of school of thought? Like, are you guys going to sort of build specific products for specific industries that use chatbots, or are you just going to sort of open source the tools and let sort of other people play around with it and build their own products? So where is the sort of company heading towards? I mean, what is the
Oh
ideology?
yeah. So I think today we don't have really um, fixed this. I think the main thing that is important for us is to keep building this open source core that we think is just very positive in general for everybody in the community. So we'll definitely keep open sourcing most of what we do. Keep building this open source core that we have. We want to make it bigger, just the same way we've built it, which is when we see that somewhere there is something that would be very beneficial for the community, that nobody has done it in a way that is at least up to our standard. Then we will also build some tools. I mean, we will expand to this, but then I think right now we won't be focusing on very specific use cases like chatbot, for instance. We may play with chatbot and make them easy to use at a very high level, like we've done. We actually have an open source chatbot repository, which implements the solution we had at NeurIPS and based on the transformer model we have. And I think we will keep playing with conversational AI because that's really exciting. But yeah, we won't like build I don't know, like if you know Rasa, for instance, we won't build like a Rasa model, like at least, I mean, not now. That's definitely not what we do. In general, we are more interested right now in helping the research community because we think there are a lot of things that can still be done by the research community if you like unlock the full potential. That was, I think, one of our conclusion when we like had the first chatbot and when we open source the first thing is that by just helping the community in general, we can unlock a lot of new advances that otherwise would take longer to be there. So really want to help the research community a lot. Yeah.
Right. So you spoke about Rasa. So we have Dialogflow from Google. So Rasa is the open source version, and Dialogflow is not open source. So a framework like Rasa, allows not just the research scientists, but even sort of beginners to sort of make chatbots or small scale chatbots. So can Hugging Face, also come up with a framework like this, probably called Hugging Flow or something like that, which could help beginners?
Yeah, so I can tell you it's not on our roadmap. I think Rasa is doing a very good job, and I think we admire a lot also how they build this open core kind of model as well. So I don't see any big interest for us to do the same thing. Probably less well than they've done. Yeah. So yeah, no, I think we, at least for some amount of time, we will focus on trying to more like do more research probably than we have done, and keep this huge mix of open source plus research. That you open source everything in a way that people can use it. I mean, just not just pushing your code out and you're like, yeah, do whatever you can with this. This is my research code, and everything is like, you have 10 variants and you don't know really which one. So we'll keep very open source in this very clean and usable thing, but also at the same time very, very close to the actual state of the art research right now, trying to push the community in this direction. So it's a bit different from Rasa as well, just because we come from different background, I think.
Right. So for a chatbot sort of company, data, I believe, is quite an important issue. So how do you sort of see that, and how does Hugging Face sort of take care of respecting the user's privacy and things like that?
Oh yeah, that's a good question. Well, so one of the good things for us first is that we are, as you were saying before, we are very clear that our bot is an AI. So it's very clear that the AI is there and will actually remember what you tell her, and that's part of the contract with the user. So there is no surprise that, surprise, I'm actually Google Duplex, so I'm sorry you didn't know about that, but I was collecting your stuff and now I'm training on your data. So here is very clear. I mean, it's an AI, and you expect an AI to remember what you've done, and actually to improve itself based on what you tell it. And if you're not happy about the answer, you actually want the AI to learn that this is not a good answer. So it's a lot easier for us to collect data. I mean, at least a lot, I think, ethically sound to collect data this way for us. So we have a pretty huge data set actually internally. We have more than, I don't have the exact actual numbers, but it's more than 500 million messages. So there's a lot, and we can try bird-sized models on our own data, which we do actually on the product. So it's I think it's interesting, and we were also thinking about maybe making some workflow that will allow and tell the user, like, do you want to participate in some research experiment, and letting some research gather data through this thing, but also in a very open manner, like the same way we do it. But yeah, the data is a big problem for conversational AI. In our case, maybe one specific problem, but it's a bit the same for everybody, is that most of our data is human to bot data. So you have to find a good way. Everybody would like to get human to human data in dialogue, but it's kind of hard to get. And so when you only have human to bot data, you have to like be aware of that and maybe process it in the good way. For instance, you usually want to model more the human response than the bot response, because you already know the bot. So if you just model your own model, you're not really learning a lot from your data set. So there are a lot of things you have to be careful about. But on the other hand, I think like making a game like what we were doing is very good, because you have a lot of interaction. When you're talking to Siri or when you're talking to Alexa, usually you want your problem to be solved as fast as possible. You don't want to talk to Siri for one day just to get your plane ticket, right? You just want, if it can understand
Not
with
Siri,
just
definitely.
one question. Yeah. And the fact that we were doing like this very creative and engaging chatbots had as a consequence that people were talking to it a lot and like just sending funny messages. So we had like I think around 50 times more message per user or per user conversation than a typical goal-oriented chatbot. So I think that's a good way to go to it. And actually, even on Mechanical Turk, when people try to crowdsource data set, now they are trying to make it more and more like a game. So like also the Turkers are more engaged and they are like giving more about it. So if people could make a data creation more like a game, I think it would help a lot to get better, more quantity and also more interesting data.
Right. So I think another problem with data would be data bias, I think, which is also an important topic right now. So in one of your talks, you mentioned that you guys are using existing data sets and also constructing data sets for your own sort of applications. So how do you take, I mean, it is very easy for sort of such biases to creep inside conversations. So how do you solve that? How do you work on that? How do you make sure that that is not an issue for the application that you're trying to build?
Yeah, so I don't think we are the most experienced in this field. Also because it's probably less critical for us. So one way we were careful about that was on the generation part, not to let the model like go on free flow generation by default. So to be sure that we control the biases on the quality of the generation. But yeah, I think on the natural language understanding part, I think we still have a lot of things we can do. Well, this is also very, I mean, it's more important now that we have this large-scale pre-trained model, which have all these biases in them, than it was before. And I think it's a good thing, because now people really try to see how we can debias this model or how we can debias the training data set. But before that, they were like, the discussion about bias was like a very small discussion, I feel. It was just a little bit of in machine translation you want to translate like a doctor by he or she and not always he, and that was mostly machine translation because it was the only field where people had like large scale data set. And right now the discussion is getting bigger in every field of NLP. So I think it's good, but we don't have like any solution right now. We just interested by this as everybody, and trying to also personally I'm trying to push to keep this discussion in the middle of the discussion, in the center area, to not say this is like for a side track on ethics. I think it's for the main track of using these models. But yeah, it's just definitely something we're following very closely.
Right. So the sort of interactions between the human and the chatbot. So the application that you've put out there on the internet, so they are more of text based. But I believe that you guys are not just focusing on that, and it's more of human and machine interaction. So what sort of other ways? What sort of other channels could this take? I mean, through voice or through sort of text, or like what are the other, directions in which you're thinking about this?
Yeah, exactly what you mentioned. So the two main are image and sound. So for sound, I think there's already a lot of very good team out there, very good, also a very good API. So we are relying on an external API to like go from speech to text and then text to speech. I wouldn't say it's a solved problem, but it's a problem that's really also increasingly be good. I think the quality of like speech to text model is now very, very, very impressive. So we don't do any research on this internally. On images, we do a little bit, but really NLP is our core competence. So we're just starting to play with images, and mostly, as you can guess, like generative models, because that's the way we are, as always, excited about stuff. So like all this ImageNet segmentation or something like that, or like classification, are not super interesting for us. We also use APIs from Google, from AWS to do like extraction from images. But we are starting to play a bit with generative and also with multimodal models, which makes sense for us, like multimodal text and vision models. I think that's really the way. That's also a way we can overcome some problems with purely text-based models. They are sometimes a bit dumb because they have never seen a picture of anything. So I think that's something that will be very interesting in the future. So we are starting a little bit, but we haven't published anything or like really open source anything on this.
Right. So, so you're a father of a young one. So your son. So I mean, while he was growing up, since during that period probably you were working on natural language processing. So were there any insights that you could take from the process of sort of learning language in humans? I mean, how we are good at it, how you could. I mean, how we could take some of that information or some insight from that and put into our machines to sort of get better results.
Yeah, that's a good question. I mean, I think it's a question a lot of people have, and like the other also have it. So the way we train this model is a bit strange, right? We like randomly sample like one sentence, and we're like, okay, this is one sentence, learn it, and then and then this is another sentence randomly sampled from the internet, and like nobody really learned language like that. Yeah, so there is a lot of things we probably will be able to do in the future. So for like for kids, we know that language is also a lot grounded in like vision and grounded in action. Like you usually associate like a sentence, or you associate words with like it can be a physical act, images, can be a speech act, can be all these things. So everywhere here we are very we don't do that in machine learning basically, and it's hard to imagine. So here there is a big question, which is do we need to have a fully embodied robot, or do we need all the modality to be able to learn really language in the way humans learn it? That's not clear. I hope we don't, because that would be very complex if we need to have like fully moving robot that you raise for like a few years before you can actually use before they can use language to do some task that you wanted to do in the beginning. So we are exploring what we can do without doing that. But for instance, multimodality is something that's interesting if we can scale the data set and train. It's very interesting. Language, just learning from language alone is still a bit strange, because in the end it's just about co-occurrences of words. Just like these two words are close, and these two words are also close to each other. They are often said together, but you feel like there is a limit to what you can learn from that. It's still super interesting that we managed to get models that's good without having any other external input. But in the end, I don't think we can reach like AGI or any kind of like thing where we would say this model understands text just by using text alone. So we have to find another way.
Right.
Yeah.
So you also made a sort of a pet project for your son. It's called Magic Sand. It's on GitHub, and it's kind of an AR sandbox. So what was the inspiration behind that? I mean, I saw the project and it was really cool. But what was the inspiration behind
one. That? Yeah, there was this. I think so. I saw there was an original project actually from UC Davis. A researcher at UC Davis has built one version of this. It was very hard to use. You had to install a very specific version of Ubuntu and compile everything, and it was all command line. It was really, very well made from a software point of view. Like the code was very clean, but the user experience was really not that great. And I wanted something that basically my kid could play with. Just very. And so I decided to make one version that would be open source, and that would be with a good user experience, with like graphical interface and everything. And so I built one for his third birthday, and it's really cool. He's still playing with it now, and it's been like 3 years. It's probably the toys that has the longest life among all the other toys. It's a bit messy because it puts things everywhere in the living room, so I'm not allowed. My wife does not allow the handbag to be always there. And then I open sourced it. I posted on the internet. I also wrote a tutorial with all the things. So if you want, you can really build it. It's very easy to build. Well, at least it's very cheap. You can just buy a Kinect, which costs like $15, I think now, used Kinect. And if you have a Beamer, then you can just basically build it with a few pieces of wood. And it was my first project that went viral because it went on the first page of Reddit. I was like, okay. And everybody was like, hey, yeah, that's really cool. You should build one for me. And then I was like, okay, maybe. So for once, I thought about starting a company building sandboxes for kids, which is maybe something I would do in the future. But it was really cool. And it was all about... the funny thing is that it was also using CUDA or like OpenGL kernel to do the shader, and this was like my first GPU experience to make this thing work. Yeah,
You would have learned a lot, I mean, during the process.
Yeah, I learned a lot. I still had a lot of things I wanted to do with this project that I haven't done, like have a game where you would have a city that would build itself on the sand, and you would be able to like play with this. Just the idea was also to get my kids to play with some game that would not be on a screen, but would be like in real life, like a video game that would be actually something you can interact with your hands and like playing with sand at the same time. So yeah.
Quite cool. Right. So what advice would you give to sort of people starting up right now in machine learning or deep learning or NLP, or I mean, what sort of things that you learned along the way do you think that can help people sort of be better at what they're trying to get into?
Yes. So, wow, that's a big question. I think don't underestimate the time it takes to be good. I think in ML it takes a few years, however fast you go, and probably have a longer term interest than just doing ML, like something that you like in the end. Like, yeah, like for me, it was always clear that NLP and generative AI were really the thing I wanted to do. And so it's good because then you can screen some stuff that you don't really want to spend time on. And then, yeah, you need to, once you think like you have the background, it's good to start really playing with the models and to start really diving into the code, because that's where you really learn stuff. And that's where you start to see also what you actually don't know and what you need to do. So like build toy project, like it's also a good way then to showcase them to companies. Yeah, I've built this. You can see the GitHub, and you put the results on your GitHub, like the images that you've generated or the thing that you've done. And just, yeah, not just rebuilding stuff, but trying to build stuff that are a bit specific to your interests. Not just training an LSTM, say, see, yeah, there's a repo I've trained in LSTM. No, but like you're like, okay, I had this weird idea about LSTM and I tried it and it didn't work, but I tried it and you can see the code, and that's the most interesting, I think. That's where that's where you can show that you've got some interest that goes behind just following the hype, I think.
Right. Thank you so much. So one last question. So you've done it all. You've attended business school. You've done physics. You've been a programmer. You've done law. Now you're a science lead at an NLP company. So what is left for you to achieve? Could I see you sort of into biology or history or art? I mean, what is left for you to explore after
Maybe.
this
Yeah,
sort
I
of
think it's
range of subjects?
I mean, life is too short to do just one thing, right? You should do all the things you want to do. It's yeah. So don't hesitate. I mean, one advice I think maybe is just don't hesitate to change career if you're not happy. I mean, well, try the thing, but after after 4 to 5 years, you can change. It's okay. You can start all over if you want to do something new. It's I think it's the most interesting thing I've done is every time I change fully, and then you start fresh and you're like, wow, I'm learning everything, and that's really cool. I feel new. So yeah,
Right, and
don't
even I think you
stay
can agree
too bored.
that everything that you learn along the way, it's going to help you sometime in the career. So,
Exactly. Yeah. Sometimes in strange way, right? But like my lower lawyer background it helped me a lot. Mostly because I was billing by the hour, so I don't spend hours like on nothing now anymore. I'm always like, oh, I spend 1 hour doing nothing. I have to do something, yeah, which is good or bad, but it's now it's also part of myself. So yeah, that's funny.
So we'll cut this here. Thank you so much, Thomas. Thanks a lot for being on the show. It was nice talking to you.
Yeah, thanks. Thank you.